Good morning, everyone. Good morning. Welcome back. Hope everyone enjoyed the previous video. I found it a good topic and something good to get stuck into. I hope you all did too. Um, so we're continuing here on part two, where I hope I can finish the job here and add a bit more context to the stereographic projection. So last time what we did, we defined the script, or we programmed the script so that we can output the stereographic projection points of each of the cities that you see currently. And we also created a map using with those stereographic coordinates on the map. So that was all well and good. Tricky. I understand I realized I got into a few snags and hit a few stumbling blocks. This is always a learning curve. And I appreciate it. I will always be one to learn from my mistakes. And this here, I suppose, is also learning from my mistakes as I move forward. And with your help as well, help in the comments too for anything that I get wrong or anything I could do better. As I say, it's always a learning curve. So thank you. Thank you for bearing with me. It is July 28th, 2025. It is Monday. And I'm hoping I can finish this all off as I wanted. So this will be part two, and I hope it doesn't go on for another 30 minutes. I'm sure you wouldn't appreciate that, but I'm going to try my best. So what do we want to do? We're not going to add any more projection points. We're not going to add any more cities. We've already created the graph, but what I wanted to do to give this a bit more context was to add an equator to this. So the equator is one of the more distinguishing features on the Earth. It's a fixed point or a load of fixed points around the Earth, and it gives, let's say, context to this map. So I hope I can do that without problems. But before I do that, I'm going to go back and I want to clarify a few points that we encountered last time. So again, here I had my contention with these grid points here. I'm going to have to live with it. The internet seems to have all sorts of theories as to what these can be. For now, I'm simply going to have to live with it. I'm going to live with that and move on. So I also realized I was defining my actual projection points incorrectly. So I knew it was here. I wrote projection, but when I did this first time, it was projections. So I kept getting into all sorts of trouble here because in my head I was saying I know it's projections plural, but for something, why is it telling me that I have a problem with projection singular? And it's because I've been mismatching this throughout. So now if I do this again. Great. I'm simply changing the list or the parameter or the object to projections. So these ones here don't matter because they're simply titles. I don't need that. But my biggest problem here was, as you can see here, if I go down to the bottom, my dots don't extend all the way to the end. And I realize why now. It's the difference. What is this console write and console write line? So if I simply remove that, then I get all the way to the end. Good. So why does it do that? So the console write, or let's say the console write line is definitive. No, it's not. It's terminative. I don't know. It terminates, meaning that whenever it sees a console write, it'll write whatever it is. So in this case, the indexes of the city points, 1 for London, 2 for Madrid, etc. And it'll stop there. So then it's signaling to the console, I want you to go to the next line now, and I want you to continue with the ellipse, or if it's a city, etc. Keep on doing this. And which is why it was moving to the next line. So the best way I can describe this is if I write this shortly, give you a small example. Move that down, move that down, move that down. And if I change that, B, C, D, E, or R even, no, I don't mind that. And then line there. And if I get rid of that briefly, then what this will show us, no, it won't show us anything because I've got the E. Good, there we go. A, B, C, D, and with the syntax indicating the right line, it's telling the E to go to the next line. Very simple, but I was getting that wrong. So let's start again. Not start again. Let's start from where we left off. So I'm hoping again. Hoping I can do this seamlessly while bringing out the equator points. So let's get on. Let me get my thoughts together while we do this. So let's go to the top. So I'm gonna get rid of that. We don't need that. Make this slightly larger. Enhance. So let's create this new this new object here, and we're going to define it not with the 5 parameters that we did for the projection points. So list, we only need the stereographic U and V. the okay, close that the semi. Okay, and what now do we need to set up a means for the equator? So what does that mean? The equator is simply a circle, isn't it? It's defined as the point at the latitude, not the meridian, the latitude, at the very center of the Earth, I suppose. It's with spherical polar coordinates x, y, z. It's the point where z is simply zero. X and y can do whatever it is. Z is simply zero. So we can define that, I hope, simply, again, using these Cartesian coordinates up here. So where do I want to go now? So let's create, basically we want to create a circle on the map. So this should be, I think, straightforward, because remember the projection point is the North Pole. So it should be looking down at each point on the equator, I suppose with equal distance from the North Pole. Okay, so convert the coordinates. Where do I want this? So let's create another one of these. So we want to create a loop that defines the equator, or a circle. So int samples. So we want to make this equator up of, let's say, 100 points. Let's say 50 maybe. Maybe I'll show you that, but let's say 100 to give it a complete full circle. J, K, J. For all the j points less than the number of samples, which will be 100. Keep this running as long as we have j to run over. What else? So let's define theta. So now we're sort of converting two spherical polars. No, plane polars. Yeah, okay. Using the pi. Pi in this case is capital letters, two capital letters. I made that mistake when I was first doing this. Very frustrating. Not capital P, lowercase I, but capital P and capital I. Okay. And now we want to define the Cartesian x. So this is cos theta. Problems. And we're going to do the same with the y coordinate, which is the sine of it. Okay, and as we specified before, it was z is simply 0. Okay, so now we want to associate the stereographic coordinates with these, and stereographic, and here we're linking the function that we defined way back at the beginning, stereographic project, x, y, and z. Okay, and we want to define the actual equator points whereby we can associate it with the stereographics. Okay. Very good. So I'm happy with that so far. If this runs, will it give me any issue? Yeah, namespace double. That's clever. Where have I used double? No, what are you talking about? Type namespace name double. Have I not seen up here? Double. There you go. Great. Okay, so still nothing added to it because that doesn't quite tell the full story here. So we're going to need to do the same as what we did earlier with the cities. So let's add a boundary for these. Otherwise, if we don't, then we risk the equator points simply falling off the map. So the boundary, it's to give it a bit more, let's say, context, I suppose. Without the boundaries of these, then we would simply have cities floating off into space with no relativity, no relativity and substance, no measure between them. But we have to define the boundaries for each of these points, so the cities and the equator. And I think we can get away with doing the exact same thing here because we're using the exact same stereographic projections. So I'm going to get away there with doing that. So if I go back a bit and no, I'll go back a bit later. So let's build that up. So we want to, how do we, scaling the equator. Maybe I should, okay, scaling the equator. So let's create, so remember this is a circle we're dealing with, not dealing with a simple list of points. So we can't use a for each as we did with the cities. So we have to register the points using hash set. So remember the circle is a load of points. That's all a circle is. The definition of a circle is a set of points equidistant from a focus, a center, if you will. So it's not necessarily defined as a big round thing of varying radius or something. It is simply a list of points, all equidistant from one single point. Okay, so concentrate you and not double again. Good. the with these points at the end. Good. So points, points. Okay. So I want a loop there. Is that correct? Yes. Yes, that's correct. Okay. So for each, yeah, var and uv in the points that we defined earlier. Okay. So, and we want to scale it again using this. So whatever point it is, we have to find the largest of the equator points. And for each current equator points, we simply want to scale it through or scale it against the max to give it a proportional place within the 40 by 40 grid or whatever it is. 40 by 40 grid, we're giving it a proportional place within. Okay, so grid set dot add. So here we are. This is us placing it within a row or a column. Okay, so that should still run. Yeah, no problems there. So because we're dealing with these, for some reason we can't stand alone not use that. I need to actually take that and I need to register those points. I need to register the equator on the grid itself, but I need to also, let's say, allow some means by which the grid recognizes all the points. That's probably the best way, the most inarticulate way anyone could define this. Okay, so let's add this to the map now, and I can do this, I think, the same way as I added all the cities. So above the cities, below the cities, yeah. Okay, so else if now, so if it's not a city, we want the equator points, right? If it's not a city, it's either it's going to have to be an equator point. Sorry. Okay. 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 Console.write. And how do we want to indicate this? Let's simply indicate it with a plus sign. Okay. So I'm hoping this pulls through. Nope, that's not going to pull through. Okay. So no, the equator grid. Name equator grid doesn't exist. Have I done something incorrect? Equator grid. Yep. Grid. Equator grid. Equator grid, yes, I've done it. I have registered it. Are you giving me some problem? Okay, good. Okay, what is that? Let's have a think, sorry. Okay, I need to do something else. Yes, because I'm using, where is it? Yeah, it's, what did I say it? It's these hash sets that I'm defining the circle, so I can't simply use that. I think it's up here. I need to define an actual hash set. Okay. Okay, int. Okay. Equator grid. So if I add the equator grid this time, so that will be our object, let's say. So would this work now? Great. Okay, so does that give us? I'm gonna zoom out a bit. Look at that. Look at that. Okay, so that's our equator right there. So that should be 100 samples within, I believe. We're good. You can see, what is this? Which one is city 10? So which city 10 is the only one? Salvador, Brazil. Okay, so that's the only one that falls within the stereographic projection there. Is this something to do with north and southern hemispheres? Brazil. Is this the only one that I've put in the southern hemisphere? Cape Verde, Praia. That could be a close second. I'm not sure where that is. I don't think that is. Okay. Was it? Yeah. North, 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 close. North, yes, north. Okay, all right, that's interesting. Okay, so everything above in the northern hemisphere will appear outside the stereographic equator list. Okay, so that's very interesting. Okay, so great. All right, I'm relatively pleased with the progress we made here. So there's the equator point. Okay, there's the equator point there. Interestingly, who founded this principle of the equator? It's hardly mathematically defined. It is simply the point where z is equal to 0 there. By definition, it's the 0 latitude. And I believe this is attributed to the mathematician Eratosthenes of Cyrene, hailing from about 200 BC. For those who might be familiar with the sieve of Eratosthenes, and no, this is not some kitchen device that you'll find in your utensils. The sieve of Eratosthenes was a means by which you can devise the prime numbers amongst a set of numbers. That was it. So amongst other hobbies he had, he took his time out to find the equator. So again, Eratosthenes was also the guy. He was the first one who managed to what is it? Determine, I suppose, or derive the circumference of the Earth. He didn't have a spaceship or anything or a telescope. Maybe he had a telescope. All he had was the length of daylight, or the period of daylight, and a few shadows, and I think, and that's how he did it. Okay, so moving on. It's 15 minutes now, so I'm going to try and do something else. So what I'm going to try and do here to give it more context, I'm going to add in the Tropic of Cancer and the Tropic of Capricorn. So the Tropic of Cancer and Capricorn, they're defined as the zones whereby which there is still, I believe, daylight above you at noon. So within these zones, you will still see daylight at noon. If you don't have daylight above you during noon, then you will not you're not falling in this zone between the Tropic of Cancer and the Tropic of Capricorn. So those will be more circles, but it's not simply z equals 0. But there's an angle somewhere, and I believe it's a 23 degree angle or so above the Earth. It's not simply z, but there's the Tropic of Cancer is a 23 degree, 23.4377, something like that, degree above the zero latitude, and the Tropic of Capricorn is negative 23.4377, etc. degrees below the latitude. So let's add that in, and I'm hoping I can set this up rather straightforwardly, and I can copy the definitions for. I'm going to start with Cancer, and then I could probably copy over all the definitions for Capricorn. Okay, so list. So again, I only need W and the double V. Okay. Okay, good. That, and I'm probably going to need. Okay, no, one thing at a time. Yeah. So what else do I need? Going to need to do something different. Oh, goodness gracious. So creating the map. I'm hoping I can use the same definitions for these. Yeah. So I'm going to have to use those samples again. Okay. So why would I need that? So, okay. Let's try something else. So to create the Tropic of Cancer. Okay, so I said it before. So what is the angle? Sorry, it's phi. Using the angle phi now. 5 degrees. What is it? 23.4377. I think it is. Okay, and so on. Let's define that again. So double phi radians equals phi deg. We're converting the phi angle now into radians. Math.pi divided by 180. So let's define the z point of the Tropic of Cancer. So that, again, we're using a circle, but we're not using phi theta degrees. What is it we want? So, yeah, phi radians. Okay, and we're going to do the same with r. Oh, so now we're using polar coordinates. Okay, cos phi radians, yeah. Okay, so then we're going to define that for each of the, yeah, I think I can just use you. Yeah, okay, I'm going to copy that. Great. Okay, so we're not done yet. Samples. Yeah, okay, so that's the polar coordinates, but we also need to define them for Cartesian coordinates. Times math.pi times by the j over the number of samples. Yeah. So find the x r times by the math, the cosine of that theta. Okay. And do the same for the y. Y is equal to math sine this time. Yeah. Sine theta double z. Yeah. Good. Okay. That's not which we've already defined yet. Okay. Oh, okay. And we need to do the same and add. I'm going to add. Yeah. U. And what else do we need? The actual Cancer points there. Dot add. All right. So are we looking good so far? Yeah, don't need a. I will need a hash set at some point. but I don't know if I can. Can I use the same hash that I used previously? I'm not going to risk it. Okay, so hash set in int. So let's bring up that cancer grid again. Okay, equals new. Will this still run? Do I have problems for now? No. Contains for. The math does not have a definition for con. Math does not contain a definition for con. So what have I done? Math con cos. There we go. Okay. Sorry. Z cancer does not exist in the current context. Of course it doesn't. Why not? Yeah, okay, all right, that's it. Lowercase, yeah. Great, okay. So it's still not outputting in the map because I haven't told it to. Okay, so what do we need to do? The hash there, and we're going to need to do this as well. Define the boundary. Okay, and I can copy that and cancer points. Okay, so why is it? I was having to think about why do we call it the Tropic of Cancer? So way back in Eratosthenes' time again, it's Greek, isn't it? Tropikos means turn or to rotate, to turn, and so the Cancer part was it was when it was at noon in the month of June. So I think that's the point. Noon, daylight above your head at noon, observed in June only. So at this point, it was. This is the points where the constellation, the Cancer constellation, is viewed above. So that's why it's called Tropic of Cancer. If we go back, why is it called the constellation of Cancer? I don't know. Okay, so I'm forgetting something. I'm forgetting something very important. Register point. I think I have to register the points like I did earlier up here. No, no, I don't need to do that. I don't know why I don't need to do that. Register the points. So I think I can get away with simply saying Cancer grid and Cancer points. Oh, great. Still running? If it does, no. Okay, Cancer points. Cancer P0 Great. Okay, so that means the last thing I need to do is add the else, the else if. Good. Okay, so this should be a simple addition of the Cancer grid points. Okay. Cancer grid. And how do I want to indicate this? I will simply call it CN. Okay, so now what? Great. So great. Look at that. That is fantastic. So what is this? So only 9. What is 9? 9 is Cape Verde prior. Okay, so yeah, I'm starting to think. Yes, is that it? Yes. So everything else lies above the Tropic of Cancer. That's right. London certainly does. Khabarovsk certainly does. Seattle, yeah. Okay. Madrid, yeah. No, okay, fine. This is looking somewhat believable here. Good. So I'm getting some of these offsets here on. I'm fine with that. That's not a problem for me. So this is all well and good. I'm enjoying this so far. So I'm going to finish this off now with the Tropic of Capricorn. So I believe this should be a simple copy and paste with a few minor additions to whatever it is I'm copy and pasting. So let's simply finish the job here. It's 23 minutes. I'm confident we can do this. On is Capricorn points. Capricorn points. Yep, spelling. Okay, so and then I need to do the same with the. I want to copy this over carefully. Okay, but I have to be careful here now because that's Capricorn. And I said it's negative, so diametrically opposite. Z part will be. No, no. Stop. I don't need to define that again. I don't need to define that again, but I can change that to the negative, and I'll also have to. Sorry, bring that up. That is going to be Capricorn. You are also going to be Capricorn. Okay, negative, that's all fine. Dot, I don't think I need to add anything else to that. Will this still, do we have any problems? Great. Great so far. Okay, so I think we're going to need to. Uh, what's next? Yeah, add that Capricorn grid. So here we're defining again the set of points that will Capricorn grid. Yep. Okay. Okay. So we mentioned these there, Cancer, Capricorn. I believe these are also zodiacs as well. I have no idea what months these are. If anyone in the comment section, if anyone watching this video is born in has the star sign Cancer or Capricorn, let me know. Okay, so okay, let's finish that for each, and this will be the Capricorn points. Okay, you should still run. Okay. Now what? I'm trying to think what was the next step. If I move down. I don't need for each of the cities. I don't need the same hash set because we're still hashing this out on the same set of samples, let's say. Um, so all I need is that. So I think Capricorn and Capricorn. Yes. Great. So I think the very last thing I need to do is to simply add it to the grid. So I'm going to copy you again. And this will be Capricorn. Capricorn. So for those, I believe Capri is it's a goat, isn't it? A capra. In Latin, in Italian, capra. Spanish, it's cabra. Um, and so what do I want? Cap. Okay, so that should be it if I've done this correctly. Goodness gracious. Where's it gone? Where's it gone? I've done something incorrectly. I think it is that negative there, yeah. That the Tropic of Capricorn has some sort of negative in there. Okay. Nice. Yeah. Silly boy, what have you done? X, Y, Z. No, yeah, you forgot to. Yeah, there you go. Capricorn. Capricorn. And then the Capricorn points. Okay, theta, Capricorn, Capricorn, Capricorn. Great, look at that. Look at that. That is fantastic. Oh, okay. That looks good. I'm happy with that. Look at that. So there it is. We've created a stereographic map. That looks it's clearly not to scale, but we've outputted all the points that we wanted to here, and I think we've made good progress here. So I think the last thing we can even add is a legend here of some form. I don't think I'll have time to do that if I keep this within 30 minutes. I won't do that. I won't do that. But anyway, there it is. Here's your a stereographic coordinate map there. And that's what it looks like. I can't believe that turned out well. So it's primitive, it's simple, and I've made a load of assumptions here, but that's what it looks like. What does this was the whole premise. What does a 3D sphere look like on a 2D map? So we've used the mathematics to collapse three dimensions into 2 dimensions, and we've made a rudimentary map. I hope nobody's planning to sail from I don't know, anywhere to anywhere using a map like this. Get a real map. And who knows, maybe we can add a bit more context to some of these to this map later on. Maybe we can add the Arctic, Antarctic to it. I don't know, for anyone who's ever gone for a hike on Offa's Dyke, we can map that maybe. The original marathon, trace that out. The Inca Trail maybe, Hadrian's Wall, the Great Wall of China. I don't know. Sherman's March to the Sea. All of these points, they're all trails, lineages. They're not perfect lines, which might be a bit of a problem here. We might actually physically have to console write lines across here. As entertaining as that is, let's leave that there. I'm pleased with the progress we made. And again, thank you for all of you for sticking with me here. I hope you found this enjoyable. I hope you found this interesting. And yeah, as always, any comments, any criticisms, anything I could do better, leave a comment and I'll happy to act on it, happy to respond. Yeah, I realize I'm still using programmers. I know. I haven't fully gotten around to upgrading to C# using Visual Studio. I'm getting there, still on this new laptop. I'm getting there. But anyway, July 28th, 2025, Monday. Thank you again. Thank you, everyone. As a quiz question, finally, if anyone can point out the 13 countries that lie on the equator, leave them in the comments as well. There's no prize, but take that as you will. So anyway, thank you so much, and I will see you in the next video. I'll see you in the next video. Thank you very much, and have a good day, everyone.